Good morning and welcome all of you to Electrical Engineering 1 tutorial session. In this session, I will be discussing about the three concepts of KVL, KCL, and power. As you have seen that in the last session, we have seen current division and voltage division principles. Okay, am I audible, all of you? Do you able to hear my voice? Uh, do you able to hear me? Please respond me so that I can understand you are listening to me. Am I audible? Umar Naif. I think there's problem with the sound. Yeah, do all of you able to hear me now? Yes, all of you, do you get my voice? Okay, thank you. So, okay, that's great. So let me solve the problem. As I've told you that in the previous session, already we have seen voltage. Yeah, in the previous class, we have seen two concepts. We have seen KVL, sorry, current division, and also we have seen voltage division principle. Okay, and we also have seen that if the resistance are in series, okay, if the resistance are in series, okay, R1, R2, then the equivalent resistance is just we add them. If you see that you have two resistance, they are in parallel. Okay, so R1 and R2, the equivalent resistance will be R1 R2 by R1 plus R2. Okay, this we have seen in the previous class. Now today in this session, I will be discussing problems on two concepts: Kirchhoff voltage law and Kirchhoff current law. And also we will see the one problem on power. Okay, I think already this has been taught to you in theoretical class, so let me solve the problem first. So see, this problem is about current division, which you have already covered in the previous class. Okay, so you can solve this problem. Okay, I will go for another problem number 5. Okay, so I'll just go another slide. Yeah, we'll just try to solve this. Do you able to see my screen clearly? So now here, let us try to solve this problem. He has given that in the network in figure 5, I naught is given as 2 ampere. So this is I naught, which is given as 2 ampere. Okay, and this is the voltage source, this plus and this is minus, and you have resistances, and this is Vs, this is plus and this is minus. Now we know that resistance is always it's a passive element. Okay, it's a passive element. What do you mean by passive elements? Passive elements generally they absorb they absorb the power. Okay, so we know that power supply and power absorb if you have any element, okay, and you have this is the polarity, okay, then if the color current, what do you mean by absorb, always you know that current is flowing in the passive elements from positive polarity to the negative polarity, okay. So this is so this is the current flowing, okay, in resistance R. Now you see here what we have to do is let us make this logical things. Suppose that here you have a voltage source Vs, then how much current you are flowing? So let me call this current as V of Is, okay. So I just mark it with some color. The current which is flowing in this circuit is Is and voltage is Vs. So let's say it's an Is, and you have a resistance, okay, and you know that the current goes from positive polarity to negative. So this is plus and this is minus, and this Is comes here, and again this Is gets split into I naught and some other current here. So let us call the some other current here is I2, for example, okay, I2. So now what happened at this point, okay, Is is divided into I2 and I naught, okay. We know that Kirchhoff current law. According to the Kirchhoff currents law, okay, Is is equal to I naught plus I2, okay. This is our first equation. And similarly, it means I2 is moving from here. This is positive and this is negative, and this is positive and this is negative, okay. So now what do we do is for solving it, our goal is to find Vs. So he's asking us to find Vs. So how do you find out Vs? So in order to find Vs, we have to find out uh, Is. Okay, we have to find out Is because V is equal to I into R. And how do you get R? R is the let us see using KVL and KCL. How do we solve them? One is just by finding equivalent resistance and all we can do that. But because here you have two voltage sources, now according to this, you can assume that the current is flowing in clockwise direction. Okay, so let us assume that you have this is suppose one loop. I call it as loop 1, and then I will call this as loop 2, for example. Okay, so we have two loops, loop 1 and loop 2. So let's label them as loop 1 and loop 2, and Is is the total current that gets divides, okay, as I have shown you in equation 1. Now let us apply KVL. So KVL we have to apply in these two loops. So now you see here already we have all known elements. So first we will apply KVL in which the values are known. Okay. So here one more thing is remember note, you just note down this point. Okay. We take for this tutorial, we take sign of uh, current at the we take the sign of current leaving side, okay, the element from where the current is leaving, of current leaving, okay. Now you see here, so let us apply KVL in loop 2. Now you see, let us, I'm starting from here, for example, okay, plus minus. You see, current leaving is from minus, so this will become 2 minus 2 into I2, okay, minus 2 into I2. So I write minus 2 I2. Then again here minus 12, okay. Then from here you are going, yeah, then I naught is flowing here. Now you see, uh, in this logical current is living at the positive side of this resistor. So we will take this as plus 8 I naught. Okay, plus 8 I naught is equal to 0. Okay, what is this? This is your KVL. So we applied KVL. Now let us solve it. It's already given that I naught is equal to 2 ampere. Okay, so therefore it's given that I naught is equal to 2 ampere. So I will call this as equation 2. Okay, I naught is equal to 2, we will in equation 1, sorry, equation 2. If you put this in equation 2, minus 2I2, okay, minus 12 plus 8 into 2 is equal to 0. Okay, so um, let me solve here still. Now I will take this minus 2I2, okay, as it is equal to this minus 12 will become plus 12 here, and this minus 8 into 2 will become plus 8 into 2. After equal to, if I take, it will become minus 8 into 2, 16. Okay, so here minus 2I2 is equal to minus 4. So this minus get cancelled. Okay, therefore we get I2 is equal to 4 by 2, which is I2 is equal to 2 ampere. This is we got. Okay, somebody asked any question? Got one message, let me check. Yeah, uh, Amr Jalal, you have written minus 2. It is not minus 2, it is plus 2, correct? It is not minus 2, it is plus 2, because minus minus get cancelled. Okay, yeah, so now I got this. So this value of I2 and I naught we will put in equation 1. Okay, so see here, this is the equation 1. Okay, we will put I naught is equal to 2 ampere, and just now we got I2 is equal to how much? 2 ampere. Okay, so we will put in equation 1. When you put this in equation 1, so Is is equal to, okay, I naught is 2 plus I2 is 2, so this will become 4 ampere. So therefore we get that Is is equal to 4 ampere, correct? So we get Is is equal to 4 ampere. After getting Is is equal to 4 ampere, now we have to find out, actually our goal is to find out Vs. Remember, this is our goal. We have to find out Vs. Now here we apply Vs, we apply KVL in this loop 1, and here all the values are known, then we can easily find out Vs. Okay, so now let's write, therefore apply now, apply KVL in loop 1. If we apply KVL in loop 1, so now you see the current is leaving from negative polarity of resistance. So what is the current here? Is. So minus 4 into Is. So minus 4 Is. Okay. Then again minus 8 I naught. Why minus? You see current is leaving from a negative polarity, minus 8 I naught. And here it is leaving from the positive polarity of the voltage element. So we write plus Vs. Plus Vs is equal to 0. This is your equation 3. Okay. Okay, somebody asked question why minus 4. Okay, now you see why minus 4, because you see here the current is is. Is going in resistance 4 ohm, but is is leaving from the negative polarity. So we are taking the sign of current leaving the we are taking the polarity of current leaving side of the element. Okay, so you see current is leaving from negative polarity, so that's why I take minus is. See here why I have taken minus 8 I naught, because you see current here I naught is leaving from negative polarity. Why I take here plus vs, because you see current is leaving from the positive polarity. Okay, so either you can take current entering or current leaving, but whatever you are taking, you have to follow it consistently throughout the problem. Okay, is it clear now? Okay, so now what we will do is, let us simplify this to get the value of Vs. Okay, so equation 3 I am solving. Okay, Vs is equal to, I will take all these terms after this equal to sign, so minus will become plus. So this will become 4is plus 8 I naught. Okay, but we know that the value of is how much? 4, and value of I naught is equal to 2 ampere. This is given. So we'll put this value in this equation so that we can get Vs. Therefore, Vs is equal to 4 into 4. Okay, Is is 4 plus 8 into I naught is 2. So this is how much? 4 for the 16 plus 8 to the 16. So therefore, Vs is equal to, you will get 32 volts. This is the solution. Okay. So by this, we have solved. Yeah, right. It is 32. So any questions, all of you, in this problem? Do you have any question? Is it clear? That's great. Okay. So yeah, that's great. Thanks for your response. So what I'll do is, let's go for next problem. So let me save this slide. Yeah. Now we'll go for sixth slide. Yeah. Again, there is one more problem here. In the network in figure 6, okay, is shown here. Figure V naught is 12 volts given here. V naught is equal to 12 given here. Yeah. So now let's see. You see, V naught is equal to 12 is given here, and we have to find out Vs using KVL and KCL and also Ohm's law. See, we know that Ohm's law is what? V is equal to IR is the Ohm's law. KVL is within a loop. There is voltage. The sum of all voltages is 0, right? And KCL is the current entering the terminal is same as current leaving the terminals. Okay. So now here you have Vs. So he is asking us to find out, in the solution he is asking us to find out Vs, and also uh, V naught is given here. This V naught is given as 12 volts. You see it is given already here, this value. So this is positive and this is negative polarity, and anything there. Okay, so yeah, this is the given data. So now let us, how do you solve this? For solving this, okay, we need to find out Vs. So we should apply our loop calculations here, but Vs is not known. So what we will do is, we will try to get the value of Vs by solving all the loops from right to left. Okay, so let us first assume that in this circuit the voltage is Vs and the current flowing in this circuit is Is. Okay, let us assume that the current is how much? This is Is. Okay, and you know that current always flows from from resistor is from positive to negative. Okay, now you see at this point of time this is is getting divided. Okay, is is getting divided into two parts. So let us call this as like this. The current, how much is going here? So I will call it as suppose I2. Okay, and the current which is going here, so let me call it as ix. We don't know how much, anything you can take, I1, I2, or whatever it is. Okay, I'm taking it as an ix, for example. Okay, now you see, then if current I2 is flowing here, then I will just, this is positive and this is negative. Okay, and now this ix is coming here. Now ix is getting divided here again at this point. Okay, so you see, I will write at this point, this is node 1, for example. Okay, so I will write at the rate node n1. Okay, I apply KCL. Okay, so KCL says that is is equal to I2 plus ix. This is equation 1. Okay, then here at node 2, let us, I will call this as node 2. So again at the node 2, we'll apply again KCL. So at node 2, what happens? Ix is equal to, now this Ix is getting divided into again two parts. So let me call the current which is going in this is I naught. Okay, and the current which is going here is I1, for example. So at node Ix is nothing but I1 plus I naught. So I will just call it as equation 2. Now what happens? This is not a node, okay, because this is an open circuit, so current is not flowing here. So this I naught, and here also same current I naught is flowing. So because I naught is flowing, this is positive and this is negative, and this is positive and this is negative, and this is positive and this is negative, because it is a passive element. Okay. Now all of you got this up to here. Do you understood how we have got? Is it clear up to here? Okay. Now let us put the loops. Okay. So let us call this as loop 1. This is our loop 1. Okay, and this is our loop 2, and this is our loop 3. Now we will apply KVL at all the loops. Okay. So now before we go for that, you just observe this part. Okay, you just observe this part. Okay, you see V naught is 12 volt, and the current which is flowing across here is I naught. Okay, and resistance is R. So let us use this Ohm's law. What Ohm's law says? V is equal to IR, but V here is V naught. Okay, I here is I naught, and R is how much? R is 4 ohms, right? So let us solve this problem. So V naught is 12 is equal to I naught. Okay, this is 4 ohms. So therefore I get I naught is equal to how much? 12 by 4, which is 3 amperes. So therefore I got I naught is equal to 3 amperes from this. Okay, so how much this? I got this as a 3 ampere. Okay, got all of you? How I naught value, we got it as 3 ampere. Is it clear? How we got 3? Okay. So now let us apply. Now I will use a little broader one. Yeah. Apply KVL in loop 1. So write KVL in loop 1. So in loop 1, you see here I naught is going. So minus 2 I naught. minus 2 I naught, okay, then minus 4 I naught, okay, then here I1 is going plus 9 I1 plus 9 I1 is equal to 0. This I got equation 3. Okay, so we will put the value of I naught is equal to 3 here. So minus 6 I naught plus 9 I1 is equal to 0, and we will put I naught is equal to 3 ampere in this equation. So when I put this value, so I get how much? Minus 6 into I naught is how much? 3 plus 9 into I1 is equal to 0. So 9I1 minus 6 into 3 after is equal to, it will become 6 into 3 plus 6 into 3. Okay. So this is 6 3s are 18. So 18 means, therefore I get I1 is equal to 9 goes 2 times. Okay. So to I1 will become 2 ampere. So what is the value of I1 now? I1 we have got 2 amperes. So this value I got as 2 ampere. Now from this value, let us find out the value of I2 now. Okay. So I1 I got the value. So let us get the value of Acha. Another thing is, you see, we know I naught and we know I1. When you know I naught and I1, if you put the value of I naught and I1 in equation 2, I get the value of Ix. Okay. So let's write that. Okay. So I naught is equal to 3 ampere and I1 is equal to 2 ampere. We'll put this in equation 1, sorry, equation 2. If you put this in equation 2, you get Ix. What is Ix? Ix is equal to I1 is 2 plus I naught is 3, which is 5 amperes. So therefore we get Ix is equal to 5 amperes. Correct? Now after we get this, now let us yeah, any question? Yeah, it's correct. So now let us solve it using KVL in loop 3. We apply in loop 1 KVL we have applied, and also we applied this in loop. Okay, we have not applied in loop 2. Let's find out in loop 2 also. Okay, so apply KVL in loop 2. So in loop 2, you see here current is leading from negative minus 18 volts, minus 18, and the current is I1 is flowing, so minus 9 I1. Okay, and then here it is I2 is flowing in this current, so plus 6 2 plus 6 I2 is equal to 0. This is your equation 4. Okay, and we know that the value of I1 is 2 ampere. Okay, so since I1 is equal to 2 ampere, we'll put this value. So 6 I2, okay, is equal to minus 18 will become plus 18, minus 9 I1 will become plus 9 I1. I1 is 2 ampere. Okay, so this is 18 plus 9 to the 18. How much? This is 36. So therefore I2 is equal to 36 by 6 is 6 ampere. Okay, yeah, good. 36, but divided by this 6, 6 goes one time, 6 goes 6 times. So I2 we got as 6 ampere. Now I2 is 6 ampere and Ix is how much? Ix is 5 ampere. We'll put this in equation 1 to get here. Okay. So therefore, okay, from equation 1, from 1, we got Is. Is is equal to I2 plus Ix. I2 is 6 ampere plus Ix is 5 ampere, which is 11 ampere. So therefore, we get Is as how much? 11 ampere. You see, all unknowns we have found, all unknowns. Now, is it easy for us to find out Vs? Yeah, because we know Is also. Okay. So now we will apply KVL in loop 1. Now we apply KVL in loop 1. When we apply this in the loop 1, you see the current Is is leaving from positive. So I write plus Vs. Okay. Then Is is leaving from negative, minus 1 into Is, minus 1 Is. And here Ix is moving, minus 6 I2, minus 6 I2 is equal to 0. So I will call this as equation 5. Okay. Now let us solve it. Vs is equal to plus Is plus 6 I2. Is is 11 ampere plus 6 into I2 is how much? 6 ampere. I2 is 6. So therefore, Vs is equal to 11 plus 36, which is equal to 47 volts. Yeah. Therefore, Vs is equal to 47 volts. Here we have solved the problem. Yes, right, 47. So now all of you understood this? Is the problem clear? So we solved problem 5 and problem 6 also. Any question up to here? Okay, that's great. So let's go for another problem. Uh, let's okay, 7, 8. Okay, see here he is asking us to find out V naught. Okay, we have to find out this V naught using current division and Ohm's law. Already we finished this. Okay, so you can take this also as an homework, because in last session we covered current division and voltage division laws. Okay, so these two problems, problem 4 and problem 8, they are dependent on same. So you can solve this problem as an homework. So I'll go for next. Before going to ninth problem, let us first solve problem number. Okay, let's solve problem 9. Yeah, this is your problem number 9. In problem number 9, he has given that in the circuit in figure 9, the power across 6 ohms. See, this is 6 ohm resistance, and the power across the 6 ohm resistance, power across 6 ohm resistance is 24 watts, and he's asking us to find out power in Vs is how much. Okay, now this is very simple problem. because you see that all these resistance are in series. Okay, so you have to find out the power, and we know that the formula of power. So we know that P is equal to VI. Okay, what is P? P is power. But according to the Ohm's law, V is equal to IR. Since we have V is equal to IR, and this is the equation 1, and suppose this is equation 2, so I will put equation 2 in 1. So when I put this, P is equal to VI. Instead of V, I will write IR into I. So IR into I is I square R. So there is one more formula I get, P is equal to I square R. So now, therefore, we got one formula, power is equal to I square R is the formula. So using this formula, okay, let us see, we know here, we know power and we know resistance. We know power, we know resistance. I can easily find out current. So let us find out now. Power of 6 ohms is 24 watts. Okay, and current is, let us call this current which is flowing here is is. Okay, across series resistances, current is same across all the resistance. So is we need to find out, and resistance is given as 6 ohms. Okay, so let us call this as an equation 3. So we using 3 I get, okay, power 6 ohm is equal to is square into r 6 ohm. So power 6 is 24 watt is equal to, I don't know, is square, r is here 6. Okay, 6 ohm resistance. So therefore I can find out is equal to 24 by 6 whole square root. So 6 ones are 6 fours are 24. Therefore is you will get as 2. Okay, that's great. So when you get is is equal to 2, finish. We got the current here. Where is this? Yeah, we got here is is equal to 2 ampere. And once you get this 2 ampere, okay, let us know that V is equal to IR. Vs is equal to Is into R. What is R? R is nothing but R equivalent. Okay, and we know that the R equivalent, all these three resistance are in series. So 4 plus 2 ohms plus 6 ohms, all will give us 12 ohms. Okay, so R equivalent is 12, and we know Is, we can easily find out Vs. Okay, oh, not Vs, we have to find out power across Vs. Okay, so here how do you find out power across Vs? So power across Vs is equal to same formula, use equation 3, use this equation 3. Okay, power 6 Vs is equal to Is square into R equivalent. Okay, so now this is 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 how much? We got 2 whole square into R equivalent is 12. So this is 4 into 12. Okay, 4 into 12 is how much? 48. So therefore power across Vs is how much? 48 watts. Okay, this is the solution. Vs we have not found out. If you want to find out Vs, just Is into R equivalent is 12, 12 into 2 which is 24, you'll get here. Okay, so but no need to find out Vs because he has not asked, he's asking PVS. Okay, so you have to find out PVS. So PVS is 48 watts. Is this clear, all of you? This is okay, that's great. Okay, very good. Now let us solve the last problem, problem number 10. Yeah, he's saying that again using KVL and KCL. Okay, using KVL and KCL, and he has given I naught is equal to 4 ampere. Where is I naught? This is I naught. Okay, so I naught is given here as 4 ampere. Then we have to find out IS. What is this? This is IS. We have to find out. Okay, so in the solution, we have to find out IS, and given that I naught is equal to 4 ampere. Now, how do you solve this problem? For solving this problem, first you need to find out the loops, okay? Current flowing this loop. Now, this is a special case. Generally, you see here, this is not a loop. We cannot say that this is a loop. Why? Because you have a current source here, okay? So now, whenever you are having a current, so you can, write like this. See, here is the voltage source. So this entire can become one loop like this. Okay, I can call this as a loop 1 and this as a loop 2. Remember this is very important. Okay, and let us see the polarity of these elements. Okay, now you see is coming from here. Okay, so is going in this direction. So at this node, suppose I will call it as node 1. Okay, is divided into two parts. Okay, one is I1 and another is I2. Suppose the current which is flowing here is I1 and current which is flowing here is I2. Now when you see this, when current is flowing in this direction, this will become plus, this will become minus, and current is going in this direction, this will become plus, this will become minus. And from here at this point, this is node 2. Before I come to node 2, I will write that at node 1, okay, apply Kirchhoff current law. Okay, so at node 1, what happens? Is is equal to I1 plus I2. I call this as equation 1. Okay, then again at node 2, again we will apply KVL. Okay, now what happens? The current I1 is split into I naught. Okay, and let us call the current which is going here. I am just assuming this is I3. Okay, so here at node 2, okay, I1 is divided into, I1 is nothing but I naught plus I3. So I will call this as equation 2. Okay, now when the current is moving, I naught is moving from this, so this will become positive polarity and this will become negative polarity, and this I3 is moving here, this will become positive and this will become negative. Now we will apply KVL in the both loops. Okay, let us see how we'll apply KVL in these two cases. So we apply KVL at loop 1. Now you see in loop 1, okay, let us start from here. The current which is flowing here is I1. So the current is leaving from positive. So plus 4 I1 plus 4 I1. Okay. Then from here, current is leaving from negative minus 8 I2. Okay. And then here the current is leaving from the negative polarity. So minus 12 volts. Now at this point of time, current is leaving at positive plus 6 I naught. Okay. Now this is your loop 1 equation. Okay, is it clear this? How we got this value? Do you, all of you any doubt in this? Minus 8 plus 4 I1, okay, minus 8 I2 minus 12 plus 6 I naught is equal to 0. Any doubt? I got any question? Okay, repeat again. Now you see here, this is entire is loop 1. Okay, this entire is loop 1. So now you see, let us start from here. If I'm starting from here, now you see this is 4 ohm and the direction of our loop current is okay, it is leaving the positive terminal of the resistance. So this is plus 4 I1 plus 4 I1, and here the current is I2 and it is leaving negative minus 8 I2, and here it is leaving from negative minus 12, and here it is leaving from positive plus 6 I naught. Is it clear? I have written simple KVL equation. Is it okay, Ahmed? Okay, that's great. So now from this, let us call this as an equation 3. Okay. So now we will put I naught is equal to 4 ampere. Okay. Put this in equation 3. When I put this in equation 3, so what happens? Where is I naught? Okay, this is I naught. Okay, I naught we are using here, and I1. Okay. Okay. Can you just see here? Uh, can you see in the sheet this value of current is given? Is given? The value of IS is given there in the question. Here I didn't see in the sheet. If you have access to the sheet, please check. The value of IS is given. Oh, not given. Okay, if it is not given, then no problem. Then we have to find out I1. Apply KCL at node N2. Okay. So what we'll do is, okay, you see what is I1 here? Yeah, this is I1 is equal to I naught plus I3, correct? Right? So I naught already we know that it is 4 ampere. Okay. So we put, let's call this as okay, put I naught is equal to 4 ampere in equation 2. If I put this in equation 2, so tell me what happens. I naught will be 4, okay, but I3 is not known, right? I3 is not known here. So how do you solve it? You have to use KVL and KCL. Any ideas? You have any idea? Now we will do one thing. See, let us solve like this. First, we will solve loop 2, okay? Because you see here we have all unknown terms, okay? These are all unknown terms, okay? So just leave it here, okay? We will solve first, okay? Apply KVL in loop 2 first, okay? First, we'll apply KVL at loop 2 because here you see we have all these things are known so that we can get any of these values. So let us apply here. So suppose if I am starting from here, then minus 6 I naught, minus 6 I naught, okay, minus 6 I naught, then plus 12, plus 12, okay, then here you have I3, so plus 12 I3 is equal to 0, okay. So now all of you please understand this. This is equation. So suppose, okay, so I'll do one thing. Let us erase this. I will call this as equation 3. Okay. Now all of you, is this equation 3 clear? I applied KVL in first this loop because here all are unknowns. There are two unknowns. I1 and I2 are unknowns. Only I0 is known. So all unknowns we cannot find out. Only one value is known and two values are unknown. We cannot find out. So that's why what we are doing is let us first solve loop 2 first. So in loop 2, you see I0 is known, okay, and I3 is not known. So one value is known, another value is not known. So easily we can find out. Okay. So first tell me, is equation 3 is clear, all of you? Equation 3 is clear? Yeah, if it is clear, finish. Now you see, now we will put the value of I naught is equal to, put I naught is equal to 4 ampere in equation 3. So when I put this in equation 3, minus 6 into 4 plus 12 plus 12 into I3 is equal to 0. Therefore, I3 is equal to plus 24 minus 12 whole divided by 12. So I think this is 1 ampere. So therefore, you get I3 is equal to 1 ampere. Okay, I got some question. Yes, clear. Great. So how much I3? 1 ampere. Now when once I3 is 1 ampere, so we can put I0 is equal to 4 and I3 is equal to 1 ampere in equation 2 so that we get I1. Therefore, I1 is equal to how much? I0 is how much? 4 plus I3 is 1. This is 5 ampere. So I get 5 ampere. Okay, I1 is 5 ampere. Now here you see I have I1 value and I have I0 value. So I can find out I2 very easily. Okay. So let's apply KVL in loop 4 and I will call this as equation 4. So we'll put I0 is equal to 4 and I1 is equal to 5 ampere in equation 4 we will put now. So we'll put in this equation. So we'll get 4 into I1 is 5 minus 8 into I2. I2 is not known. Okay, minus 12 plus 6 into I0. I0 is how much? 4 is equal to 0. So minus 8 I2 is equal to 4 5 are 20. This will become minus 20. This will become plus 12 and this becomes 6 4 are minus 24. Okay, so minus 8 I2 is equal to minus 20 plus 12. How much? Or this is become minus 12. There is minus 32. Correct. So this minus minus get cancelled. So 8 ones are 8, 8 fours are 32. So therefore I get I2 is equal to 4 ampere. Okay. Now he is asking us what to find out what in the network figure. I have to find IS. We have to find out IS. Okay, it means we have to find out this IS, equation 1. Okay, so now I1 and I2, therefore we here will write, therefore put I1 is equal to 5 ampere and I2 is equal to 4 ampere in equation 1. If you put this in equation 1, what happens? IS is equal to I1 plus I2. I1 is 5 ampere and I2 is 4 ampere. Okay, so therefore Is is equal to 9 ampere. So we found the value of Is to be 9 ampere. So do you have any question up to here? Is it clear, all of you? Okay, that's great. By this we have completed our sheet 2. Okay, thank you all of you. Very good. So by this we have completed our sheet 2, and next week we'll be starting sheet 3. But I would like to know that I want to conduct some quiz. Okay. So what is a good time for you today evening or tomorrow evening when you want quiz? Please tell me so that I will announce that quiz and I will put the quiz. So just discuss among yourself and let me know when you want the quiz. I'll just stop the recording so that I can discuss with you these timings.